So in this video, we're going to be designing some motor mounts. It's super important to have a mechanical connection between your motors and the devices you're trying to actuate. It's very bad practice to use glue or tape or any other type of connection other than mechanical in these situations. Not to mention that it can be really bad for the motors. So we're going to be using Tinkercad to design them. Tinkercad is a really easy CAD software. It's basically like block code, but for CAD. Uh, you can pretty much do everything you can do in regular CAD except you can't simulate. So all you're going to do is click Create and then 3D. And the first thing we're going to want to do is bring in a cylinder, and that's going to be the base for our mount. Okay. And so we want to increase the sides to 64 just so it's a nice smooth cylinder. What I'm also going to do is click R and drop that in there so I have a nice ruler that shows me the dimensions. And we're going to change these to about 10 millimeters. The reason for that is because I'm doing the SG92 servos, which are about that size, or that's about the size of the mount I want. So the next step you're going to want to do is count the number of teeth on your servo. Servo mounts are actually called servo horns, and they always have teeth on them to engage with the actual mount. So the next step is to go to this website, stlgears.com. This is a super easy website to generate any type of gears, racks, beveled gears, whatever. Um, and so you can actually use this to generate the teeth inside the horn. So first, you're going to want to set the module for this one. Zero point 0.3 is the lowest it goes, so I just set it to 0.3. The pressure angle for most servo mounts is about 30 degrees. Number of teeth, I counted them to be 20. And then the gear length, this doesn't matter. I'm just setting it to 3. Then you click Download Gear. You're going to go back to Tinkercad, click Import, go to your downloads, just drag and drop it in there. Try it again. Here we go. And then click Import. There we go. Now, once that imports, the next step is to make sure that the dimensions line up with the actual dimensions of your servo. So I measured the diameter of my servo to be about 4.9 millimeters. So I'm going to add a decent amount of tolerance there. I'm going to do 4.3. That's just zero point 0.4 millimeters. That's pretty standard for 3D prints, especially when you're doing gears like this. Next, what you're going to want to do is click this up here. This will convert it into a hole. Now, what a hole does is when you group it with a solid like this, it'll basically remove it. So next is you highlight both of these, click L to align them, and then you can use these nice buttons to align your two objects. And then you're going to highlight both objects again and do Command G to group them. And there, as you can see, that looks like a regular servo horn, but with this nice base that you can just build anything off of. Next, what we want to do to have a really solid mechanical connection is add a hole for the little screw that goes inside the top of the servos. Those tend to be about number 2 screws or M2 screws. So what we're gonna want to do is increase the sides to 64. Then let's say make this around 3 millimeters so it can fit or it can fit the screws that go into the top of the servo. And then again, click L to align, highlight both, and do Command G. Just like that, perfect servo mount that should be able to fit right on top of your servo. Then you'll take your screw, put it in there, tighten it down, and it should be a very snug fit. And then, like I said, you can build anything off this. The second type of mount we're going to make is a friction fit mount. So I'm going to be designing one for the DG01D little geared DC motors. So these are interesting because of the shape of the shaft. The first thing you're going to want to do is drop your cylinder in there because, as you can see, it has a radial portion to the shaft. And so I measured that to be about 5.4. So I'm going to add a decent tolerance, let's say 5.6 there. 6. Perfect. And then I'm just going to make it 5 millimeters tall. This doesn't matter. This is will change based on your application. Now for the actual portion that's rectangular, we'll drop a rectangle in there. And I measured that to be 3.7. So I'm going to make that around 4. This is something you can play around with. Since these are small, you can print a few iterations and just see which ones fits best for you. This is pretty much what works best on my printer, these tolerances I found. So what you're going to want to do next is highlight both of these, click L to align them, just like that. And as you can see, if you chop these two planes off, you'd have that nice shape. So what we can do is click W, and that moves your work plane, and we're going to click it onto the side of this rectangle. So now our work plane is on the side, and when we drop in one of these whole cubes, let's do that on both sides, just like that, and then click W and click anywhere else, and that will drop your plane back to where it was before. And then we'll actually delete this reference cube. And then when you highlight all of these and do Command G, there you can see that's the same shape as our shaft, and the dimensions should also match. So next, you pretty much take the exact same steps as before. I'm gonna take, this is my the base for my mount. I'm gonna make this let's make that 10 millimeters by 10 millimeters by 5 millimeters. Again, this is gonna change based on your applications. So we'll make this into a hole. Click L again with the two objects highlighted, and then highlight both and do Command G, and then there you go. Nice mount that you can build off of, and this should be friction fit. So when you put it onto that shaft, it should hold itself down. So this is what you want your final connections to look like. I added just some rectangular little arms to the mounts. And as you can see, they're mechanically connected. You can design whatever you need to attach to the servos, and then just group it onto the mounts that you designed. And then it's also safe to glue things onto these mounts afterward. So as long as you're not gluing anything directly to the shaft, you should be mechanically sound.